For number 24, we've got a conical tank that's being filled with water at a rate of 10 cubic feet per minute. And we want to find at what rate is the height changing. So this is our information. The volume formula for a cone is here underlined in purple. The problem is if I take the derivative of it, I will get 3 rates dV/dt for the V, dR/dt when I differentiate the R, and dH/dt when I differentiate the height. The problem with that is I don't know all that information. I'm looking for dH/dt. I know dV/dt, that's the rate of change of volume, the water, but I don't have a dR/dt, which means I have to rewrite my volume equation so that I don't have R in it before I differentiate. This way I won't get the dR/dt. So let's do that. This cone has dimensions 10 across the top, the diameter, by 12 feet deep. And the water at any given point has a diameter d and a height of h. So those are similar triangles. The purple triangle and the green triangle are similar. So I know that the base of the little one, the capital D, is to the base of the big one, 10, as the height is of the little one, h, is to the height of the larger one. I also need radius, not diameter, because I have radius in here. So I'm going to replace my radius and my diameter with 2 radii. And then I'm going to solve for r. So that's really r. First I'll reduce that. R over 5 is h over 12. I'll multiply by 5 on both sides and get radius is 5/12 the height. So then I will substitute in this for my radius. So now I will simplify that volume formula before I differentiate. So now I will multiply the 1/3. So I get 25 over 144 times 3. Is 432. Pi h cubed. So now I can go ahead and differentiate this thing and not have a dR/dt in it. The 3 comes down and multiplies by the fraction. So now I can plug in my variables. The dV/dt was 10 cubic feet per minute. The h was when h was 8 feet. And then they want to find dH/dt, the rate of change of the height. And this was squared, by the way. So 8 feet squared is 64 square feet times the 75. So it's 4,800 over 432 pi feet squared dH dt. I'm going to reduce that 4,800 over 432. So 432 cut in half. Once is 216. then 216 cut in half again. There's 108 cut in half a third time, cut in half a fourth time. So cut in half 4 times comes out to be 27. So that's like dividing by 16. So 4,800 divided by 16 is 300. We could reduce that even more, I think, right? 3 goes into both of those. So I'm not going to rewrite the line for that. That's going to be 100. And that's going to be 9. So I will then divide by all this stuff. 100 over 9 pi feet squared. So let's look at the units first. When I divide feet cubed by feet squared, I just get feet per minute. So I know it's feet per minute. Then I'm going to take 10 and divide it by 100 over 9 pi. So, and that's going to be feet per minute. So then it's 10, instead of divided by 100 over 9, times 9 over 100. So then I have to remember, though, that pi stays in the denominator. So that goes in 10 times, so it's 9 tenths. So that will be 9 over 10 pi. Pi's in that denominator. Feet per minute. That is dH dt.